So as you can see with the title of this video, we're going to be talking about unit conversion. If you're very used to doing unit conversion, you're like, oh, I'm a pro at it. I don't really study. Just stick with this video for a little bit. I'll show you a couple key things that you probably didn't notice or know in the end. If anything, if you're good at it, good for you. So as you can see, I have a density, a pressure, a volume, and a velocity over here. We're going to start off with the density, but before we begin, I just want to rewrite this one. It should be per hour, by the way. Anyway, so this is going to be 123 psi. Psi is just pound per square inch. So I'm just going to rewrite that almost more in this form, though. So it's going to be a pound force per inch squared. That way I get this 3 or, a 2 almost. Square inch, is just a little hard to cancel things out in the end.
So yeah, as you can see, it's pound force right here, not pound mass, or pound, I guess. The main reason is because there is pound force and pound mass. So I just want to make a little distinction here because it gets a little confusing, pound force, pound mass. I'm always gonna try and put an F right here, even though this F looks kind of horrible, but yeah. I'll try to put an F or an M, just to note if it's pound mass or pound force, just to let you know as well. The main reason is because one's a force, one's a mass. The main reason for pound force is so if we have 1 pound force, it's going to equal 1 pound mass. So LBM times by basically 1 gravity in the end. So gravity is going to be 32.2 feet per second squared. There we go. Feet per second squared. So yeah, typically, I shouldn't say typically, but you'll use slugs a lot. You probably haven't heard slugs before, but yeah, it's kind of a weird term. No one's really heard of it. They're just pounds. You just go straight to weight. It's gonna be 1 slug. So you got your mass, and then times by 1 foot per second squared. So they're going to be a little bit different in the end. 1 pound mass is going to be like 1 over, gravity in order to be 1 slug, just because it's got to compensate for this being 32.2. But yeah, like I said before, the main reasoning why we have that is just because it compensates for gravity already. So sort of like, hey, it's just that's how much mass a pound force is with our standard gravity if you're just using, gravity at the surface of the Earth. That's that in the end. I'll get rid of that. It's kind of a wonky little thing to do in the end, but it's worth it sometimes just because it's a little extra step. I don't really like it personally because it gets a little bit more confusing. I don't really find it really that much more beneficial than how much more confusing it is, but it is a thing and we do kind of have to deal with it. So 1 pound mass, like I just had right here, is equal to 1 pound force is equal to 1 pound mass times by 32.2. And we're just using Earth's forces just because, we're on Earth, So we're using Earth's gravity.
So now that we have everything written out how we want, I'm going to start off with the density then. So as you can see, I didn't write this as MPH. I could have, but I don't know. I prefer, if we're going to do unit conversion, to be like this, miles, and then line, and then basically per hour. as long as it's divided up like that, it's easy to cancel the units in the end. So, but anyway, so now we're going to start off with the density right here. So rho. Rho is just the Greek symbol, and we use it all the time for density. But so what we're going to be doing in the end is just changing kilograms per meter cubed into grams per centimeter cubed. So in order to begin, we just need I just need to write down one thing. So 1 kilogram. Oh, uh, 1 kilogram equals 1,000 grams in the end. Kilo is 1,000. So what I'm going to do in the end is I'm going to divide by 1 kilogram to both sides of this. And the reason why I'm dividing by 1 kilogram is because we want kilograms to be in the denominator, so it can cancel with the kilograms in the numerator. So once we do that, both of these cancel, and essentially then we get like 1 equals 1,000 grams over 1 kilogram. So what we're going to be technically doing with unit conversion every time is just multiplying 1 every time. Uh, which in the end doesn't change it, which would make sense for unit conversion. It should be equal in the end. But yeah, so essentially we're multiplying 1 every time in here. But we're going to have like 1,000 grams over 1 kilogram. So that's why we're going to be multiplying by 1,000 in the end. But yeah, so we're going to multiply by 1,000 grams over 1 kilogram. And then these units are going to cancel out. And then now we have meters cubed in the denominator. So let me just erase this over here. Okay. So in the end, then we're going to have, so basically we need to convert meters cubed to centimeters cubed. So 1 meter is then going to equal 100 centimeter. And I'm pretty sure you knew that also. So what we're going to be doing in the end is going to be dividing by 100 centimeters to the side also. So really it's just going to be 1 meter over 100 centimeters. But in the end, like if you've taken physics before, you know that, oh, well, this has to be cubed then. So let me just show you why. And technically, you don't even have to cube it. That's the beauty of all this. So really, it's going to be, if you cancel this meter, it's going to cancel with one of these. So this is going to be meters squared now, times by centimeters. But you want it all into centimeters. So we're going to have to do this 3 times. So then you would multiply by another one. So then that would cancel with this guy, and then you're just left with meters right here. And then we'd multiply by another one. And then so you had 1 meter over 100 centimeters. And so then you're left with completely centimeters cubed in the denominator. So that's why it's 100 cubed for all this. So now if we go to our calculator real quick, so we have to do 999 times by 1,000 divided by 100 cubed. So before I begin with that, I just want to talk about this density right here. So this is actually a very well-known density in the end. This is the density of water. So 999 kilograms per meter cubed, that's the density of water. And water is incompressible, so it's always said to be this. So, well, I guess water can be compressible, but. So anyways, so now we just have to multiply that by 1,000, but then if we divide it by 100 cubed, we should get our answer in the end. So there you go. So you have 0.999 grams per centimeter cubed. So which kind of makes sense just because it should be 999, but with the decimal place moved over a couple places, just because we're in SI units with this. So yeah, so everything is just like 10 to the whatever, and we're multiplying and dividing by that. So that's why it makes sense that the decimal place just moves and that's it. So yeah, and just because we're still we're going from SI to SI still. So that's what happens. If we're going from SI to English, things get ugly, or English to English, for a matter of fact. But yeah, anyways, enough about that. So I could probably rant about that forever. But anyways, so now if we continue on, So now we need to do this pressure rate here. So yeah, this is just an arbitrary one. This is the only special one. So anyway, so 123 psi, we want to convert that now to pascals. So if you didn't know before, 1 pascal is equal to 1 newton per meter squared in the end. So really what we need to do in the end is convert pound force into newtons. So what we're going to do now is, so it's going to be 445, well not 400, 4.45 newtons equals 1 pound force. So pound forces cancel and you get newtons in the numerator. So now if we times that by, here, actually, this one's a little tricky. So we need inches into meters. So I just remember that 1 inch actually equals 2.54 centimeters. So this is the only one that I remember ever. And actually, if we move the decimal place for centimeters, then we get 0.0254 meters in the end. So 1 inch equals this. 0.0254 meters. So now if we need inches in the numerator, so see 1 inch squared. And if you're not used to doing converting right away, just keep on doing this, you would just have to have a couple more in the end, convert it from inches squared to centimeters squared, and then from centimeters squared to meters squared, if you do more steps and you just feel more comfortable that way, go for it, it's better just to write down more stuff than to just blatantly get things wrong almost, it's just this method right here is just foolproof in my opinion. I shouldn't say it's 100% foolproof because people still get things wrong, but so yeah, so really then this is going to be 0.0254 meters, or actually let me get rid of this square right here. So yeah, that way we can see all of it written out like this. So that's meters. And then we have one more for meters, and then that's going to equal, so inches, both those cancel with this, and then we're left with meters squared. So now it's time for our calculator. So now if you do 123, now we have to times it by 4.45 and then divide it by 0.0254 squared. So in the end we get this kind of ginormous answer. So instead of writing pascals, I'm going to in the end just write it in kilopascals. So really I'm going to shift the decimal place to right here. So it's going to be 848.4 kilopascals. So 848.4 kPa. So kilopascals. So yeah. So now we're in pascals or kilopascals. Same thing. So yeah. So now on to this one. So really in the end, I want gallons just changed into basically fluid ounces. So nothing too special, I guess, in the end. But here, let me get rid of this. Gotta make some room. Okay. So what we're gonna do right now is it's really just one unit conversion for this one, but I just want to get you used to this method in the end. So just do this where you're canceling things out, and I guess you can cube things also, but if you don't feel comfortable cubing things, just do it 3 times, or 2 times if it's squared or whatnot, So, but anyways, so now 1 gallon is going to equal what is it? Okay, 128 fluid ounces. Okay. Okay, so to our trusty calculator, we're gonna do 220. Not 200. 22 times by 128. I don't know why I'm off my game for saying stuff today, but yeah. So in the end, we get uh, basically 2,816 fluid ounces. So 2,816 fluid ounces. So that's our answer. So yeah. So now onto this one. So now I want to convert this from miles per hour or mph, into feet per second. So in order to do that, then we got to convert miles into feet. So it's not an equal sign. We have to multiply. So it's going to be basically 1 mile has 200. Oh no, not 200. 5,280 feet in it. And then so those cancel, and then we get feet in the numerator. So we can stop with the length then, and now it's onto the times. Uh, so so yeah, so now need to convert hours into seconds in the end. So there's almost two ways about converting hours into seconds. You can just say basically 1 hour equals 3,600 seconds. This is 100% fine, you can go around this way, but this is really just 60 squared in the end. So yeah, so I'm going to do it a little bit differently in the end. Than just use this. But if you just do uh, basically 1 hour over 3,600 seconds, then it's still fine. So it's just a little bit faster that way. But this is not about speed right now. It's just about you learning. So if you take a long time, you take a long time. But I'd like you to go fast as possible too, because when you're taking your exam, speed does kind of count a little bit, but speed does not account for basically stupid mistakes though. So I'm trying to minimize your stupid mistakes at least with all these videos. But anyways, so 1 hour is then going to have basically 60 minutes in it. So, and then 1 minute is then going to have 60 seconds. So as you can see, you can just jump straight to this just because it's 60 squared. But if it helps you to write everything out, it helps you to write everything out, So hours cancels with hours, minutes cancels with minutes, and then we're just left with feet per second in the end. So now we can get our answer, but let me erase this real quick. Okay, so now go to our calculator. So now it's going to be 50 times by 5,280 divided by 60 squared. And then there we go. So 73.3 feet per second. So yeah, so that's it in the end. So we converted basically kilograms per meter cubed into grams per centimeter cubed, psi into basically pascals in the end, or kilopascals, and then gallons to fluid ounces, and then miles per hour to feet per second. So if it takes you a little bit longer to do it this way, but you feel a bit more comfortable, I would say do it this way then, just like if you're more comfortable doing it that way, I'd pick that way for you, if I were you, but if you feel more comfortable doing it a different way, go right ahead. A lot of this is about just preference, like I think I've said before. So whatever you want to do, do it. But I'll try and help you out with choosing the right methods in the end.